Hello and welcome to this lesson on quadratic inequalities. So first of all, it's worth noting that when we're doing this you need to know the graph of a quadratic and what it looks like. Now they look like two things. They either look like a U shape or they look like an N shape. So you have to know which one is which. Now these are determined by the dominant power, and in this case it's the x squared value. So let's just have a look at an example before we start. So if I've got something like this, so y squared plus 2x minus 3. Now notice with this one that this one here is a positive x squared. So if I was to look at this one here would look like a U shape like that. Okay, I'm not going to don't want to worry too much about that now. It would look like this U shape, okay, and that's because the squared is positive. If I had something that looks like this, so minus x squared plus 2x minus 3, then this one here would look like an N shape. Okay, so this one here is a U shape, this one here is an N shape, and it's because this power is negative. Sorry, it's because the dominant power is negative and the dominant here power is positive. So that's our starting point with this. So let's have a little look at this first question. So I'll make it big so you can see it. So with this one here, here we go. So the graph of y is equal to x minus 3, x plus 2 is drawn below. Solve x minus 3 times x plus 2 is greater than or equal to 0. So let's have a little look at this one together. Now I am going to draw this down. I'm going to suggest that you do too. Make sure you get it in your notes. Remember, the only way to learn maths is to do it. So this one here is example 1. Okay. So here we've got our graph. Like so. We've got two solutions here which are minus 2 and 3. Notice that they've already solved this. I can show you if we solve it over here. So x minus 3, x plus 2 is equal to 0. So that two things that time together to make 0, which means that one of them must be equal to 0, or the other one must be equal to 0. So I end up with x is equal to 3, or x is equal to minus 2. So minus 2 and 3. Now they've already done that for you in this case. Alright, so we already know how to do this, and we already know that this looks like a U shape because it's a positive quadratic. The thing we need to do, and the new part is this part here. It says solve x minus 3, x plus 2 is greater than or equal to 0. Now it's this part here that's greater than or equal to 0. So this line here is where it's equal to 0, this one here. So this is where it's equal to 0. And what we're looking for is when this is greater than or equal to this 0 here. So we're looking for when this is greater than here, greater than or equal to 0. So when is this going to be greater than or equal to 0? Well, it's going to be this part here. So this part here is greater than or equal to 0, but also this part here is greater than or equal to 0. Okay, so what are my x values when it's greater than or equal to 0? Well, my x values start at minus 2 and go this way, so they're less than minus 2. So it's x is less than or equal to, because it can be equal to minus 2, so everything which is this side of it, or when x is greater than or equal to, in this case, it starts at 3 and goes right. This is where it starts to become positive. Notice that this is going to be negative, this is going to be positive. This is when it's greater than 0. So it's when it's greater than or equal to 3. And those there are your two solutions. Brilliant. So, with this next one, I am going to go through it with you. I'll make it big so you can see it again. So, the graph of y is equal to x times x plus 5 is drawn below. Solve x times x plus 5 is less than 0. So, let's have a look at this one. I am going to draw this one out again. It's always worth drawing these. So here we've got example 2. So here we've got our graph like so. This time it's cutting through minus 5 and 0 there. So this one here is minus 5 and this one 0. Now, remember, we're not asked for any of that here. We're just asking for solve when x times x plus 5 is less than 0. Now, the whole point here is we're looking for when it's less than 0. Now, 0 is this part here. This is when it's 0. So when is this less than 0? When it's less than 0, when it's below this. So it's all of this part here. Okay, so it's everything which is below this, which is this part here. So this is when it's less than 0. Now, notice with this one here, the one above it, that when it was greater than, it was split. So it was split because it was -2 and 3. So it's the bits were greater. The bits that were greater than 0 when it was less than -2, but greater than -3. Sorry, greater than 3. With this one here, it's less than 0 when it's connected here. Notice it's connected between -5 and 0. This is where it's connected here, like this. This one here is split. This one here is connected there. So when I do this, my inequality needs to be connected as well. So I'm starting at -5. It's just less than in this case, so it can't be equal to -5. So it's less than x is less than 0. It's between -5 and 0, between -5 and 0. So with this one here, let's just compare these two, because this is really the most important part of this. When it's greater than and it's a positive quadratic, our inequalities are split. So it's going to be everything which is less than -2 but greater than 3. When it's an inequality, when it's a positive quadratic and it's less than 0, you're looking at less than 0, notice here that it's connected, so my inequality needs to be connected. Okay, now that's really important, and if you understand that, all of this becomes pretty easy. That's probably the hardest part of this, as long as you understand quadratics as well, of course. So let's just check those answers. So there's the first one, brilliant. So you notice you've got 2 inequalities on that one, and notice on the right hand side one you've got a connected inequality here, like so. Okay, so let's have a look at this one here now. So this one here is example 3. The difference with this one is obviously that they haven't drawn it out, but I am going to draw it out, and I also need to solve this as well. So the first thing I'm going to do, x plus 1, x plus 7 is equal to 0. Let's just say it's equal to 0 for now. So I'm going to have 2 solutions when x plus 1 is equal to 0 or x plus 7 is equal to 0. Take away the 1, take away the 7, I end up with x is equal to -1 or x is equal to -7. There are 2 solutions for x. Now, if I was to draw this graph, they're both negative, so it needs to be skewed towards this way, and I'm going to draw it there like this. Okay, so this one here is going to be equal to -7, and this one here is equal to -1. There, like so. Now, what the question's asking for is when is this less than or equal to 0? So if I have a look at this, let's write it out. So we've drawn the graph, that's important, you're going to get a mark for that. We're going to draw it between, we're going to state what we're trying to do. X plus 1, x plus 7 is less than or equal to 0. So when is this less than or equal to 0? Well, it's this part here, isn't it? It's less than or equal to 0 on that u part there. Okay, and notice that this is connected. Okay, so that means my inequality needs to be connected. So it's going to be -7 is less than or equal to x is less than or equal to -1. Brilliant. Okay, so what I'm going to suggest you do is pause now and have a little go at that one on the right hand side. I am going to go through it in a second. Okay, let's go through it together then. So, this one here is example 4. Hopefully you will have got this right. Hopefully you're starting to understand this now. So with this one here, we've got x plus 6, x minus 10, and we're looking for it greater than 0. I'm going to make it equal to 0 for now so I can solve it and see where it's cutting with my U shape. So when x plus 6 is equal to 0 or x minus 10 is equal to 0, so x is equal to -6 or x is equal to positive 10 in this case, taking it onto the other side. So this time I'm either side of this. One's going to be -6, one's going to be 10. So there like that. Okay, so -6 and 10 there like so. Now, this time we're looking for when it's greater than 0. So when x plus 6 times x minus 10 is greater than 0. So when we look at this, we're looking for when it's above 0 here, above that line. And in this case, it's going to be here, so everything this side, and here, so everything that side. Okay, so everything left and everything right, everything below -6 and everything above 10. So when x is less than 6 or x is greater than 10. So these two things are split. Notice again that this one's connected, and notice that this one's split, and that's because the graph is split and here the graph is connected. Okay, let's have a go at the next one. Now what's going to make this harder, you think? So when I look at these, brilliant. So next step is going to be to factorize. Now we should be fine with this. Okay, we should be able to do this one. I will do the first one. If you want to pause and have a go at both of these yourself, you can do. Okay, but I'm going to go through the first one, and then in fact I'll put them both up in case you want to have a go at them. So there's both of those. Pause now and have a go at those if you want. Okay, let's have a go at them together. So this is example 5. So x squared plus 2x minus 15 is less than 0. So the first thing that we need to do is to factorize this. So what are the factors of 15? 1 and 15, 2 doesn't go, sorry, 3 and 5, good. 4 doesn't go, but then I'm back to 5, and because it's negative 15, it means these need to be different. So it's going to be minus 3 and positive 5 to make the 2. So it's going to be x minus 3, x plus 5 is less than 0, which means my two solutions are, so let's write solutions are going to be x is equal to 3 or x is equal to minus 5. Now notice, usually these questions are worth 3 marks. Up until this point, you're only getting 1 mark, would you believe it? Okay, so the next stage is we draw our graph. It's on minus 5 and 3. So we've got 1 here which is minus 5, 1 here which is 3. It's a positive quadratic, so it's going to be a U shape. And we're looking for when it's less than 0. So when's it less than 0? Well, here's 0. Here's when it's less than 0. Notice that it's connected here. So my inequality needs to be connected, which is minus 5 is less than x is less than 3. Notice, you might notice that with this one here, I'm not including less than or equal to, but that's because this isn't less than or equal to. When I look at the next one, it is equal to, so this needs to be either greater than or equal to or less than or equal to. Okay, so example 6. If you watch that example and you want to have a go at example 6 yourself, pause now and have a little go at that. I am going to go through it though. Example 6. So, x squared plus x minus 6 is greater than or equal to 6. I'm just going to factorize this straight away because I think that you should be able to do this now without the bit on the side. So 3 and 2, it's going to be x plus 3, x minus 2 is greater than or equal to 0. So I've got two solutions. So my solutions are when x is equal to minus 3 or x is equal to 2. It's a positive quadratic, so it's going to be a U shape. So I'm going to draw it as a U shape. Minus 3 and 2. Here's my U shape. Minus 3 and 2. Brilliant. And I want it when it's greater than or equal to 0. So this is 0 here. When it's greater than or equal to 0. When it's greater than or equal to 0. When it's above this line. So it's everything which is going to be less than or equal to minus 3. Or greater than or equal to this 2. Notice that I'm including the equals to this time because it's equals to in this part. So x is everything which is less than or equal to minus 3. Or everything which is greater than or equal to 2. Brilliant. And there are two solutions. So let's have a little look at those. Just check those are right. Super. Brilliant. So again, what's going to make this harder? So we've been looking at everything now as being a U shape. Now, this one here we notice is an N shape. Now I'm going to make this big for you. So with this one here, they don't actually give you the They don't actually give you the equation, they've just given you a quadratic graph. And this quadratic graph is already a U-shape. Now notice that it's crossing at -1 and 3, and it's asking for when is it less than 0. So if I go back to this, now usually everything we've done before, when it was less than, it was connected. But here, notice when it's less than, it's actually split. Now notice this is worth 2 marks, so this one does come up, and these do come up all the time. This one here is example 7. So I've got a graph there like so. If you want to sketch it out, it's probably worth it. It's crossing through -1 and 3. And it's looking for when f of x is less than 0. So f of x means the function of x. And it says that y is equal to f of x. So it's saying this curve is f of x. And it's looking for when f of x is less than 0. So if I look at this, this is the point 0. When is this less than 0? And now notice it's always worth drawing these parts down to show you can show the examiner and show yourself where it is below 0. So in this case it is split. So it's when x is less than -1 or when x is greater than 3. Notice it's greater than, it is going down, but that doesn't mean that it's not, x is not greater than, because x starts here. This is where x starts and it's going this way, which is greater than. This is where x starts on this line and it's going here, which is less than -1. Okay, super. So that's now once we've looked at U shapes, we've looked at N shapes. Again, what's going to make this trickier? There's our answer for that one. So it's now asking you to solve it and to see how it's to solve it and to work it out from here. Now, the mistake that everybody always makes with this is well, I'll make it big for you so you can see it. They times by the 4, then they take away the 3. But with this one here, people forget to use the graph, and people lose marks because they don't know what they're meant to be doing. Now, the best way to do this is not by solving it, working backwards, and then square rooting it at the end, because you're going to get it wrong that way. Let's have a look at this one together. So this one here is example 8 now. Example 8. So I've got m squared plus 3 all over 4 is greater than 21. Now you do need to times up by the 4, which is going to be m squared plus 3 is greater than 4 times 21 is equal to 84. Now, you might be tempted to take away the 3 and then square root it to get 9, but you're not going. You think you might get 1 mark for that, for this rearrangement. You're going to lose pretty much all the marks if you put m is greater than 9. Okay, you've got to understand that we've got to do this properly. So instead of taking away the 3, we're actually going to take away the 84 and make it into, so 3 minus 84 is minus 81, which is greater than 0. And this is actually the difference of 2 squares. So this is m plus 9 and m minus 9 is greater than 0. This is what you actually have to do. Okay, you've got to spot that it's going the other way around, and then it's the difference of 2 squares. That's why this is 4 marks, because people make loads of mistakes with this. So then I draw my graph. My solutions are 9 and minus 9. It's a positive quadratic. So it's minus 9 and 9, and we want it when it's greater than or equal to 0. So when it's greater than or equal to 0 is here and here. So it's when m is less than minus 9 or when m is greater than 9. Now if you were to over here, let's just say m squared, take away the 3, so right is greater than 81, square root that, m is greater than 9, you're getting 1 mark for that. This is what they're looking for, okay? They're looking for the difference of 2 squares and then understanding that because it's greater than, it's split like this, okay? So that was example 8. That was where we push it that little bit further. So, notice we've got 2 solutions there. Brilliant. Next little stage, and this is the last little part of this, and to be honest, I don't think this is too difficult. Now, there's 2 ways you can solve this one. I'll make it big for you. You might want to pause if you think you can do this yourself. This is worth 5 marks now. Okay, 5 marks this is worth. And this comes up in both the GCSE and in the A-level as well. This comes up quite regularly in the A-level actually. So pause now if you want to have a go at that. Okay, now there's 2 ways you can do this. You can either use the quadratic formula, or you can use factorizing, because I do think this one actually factorizes. I think that's probably why it's worth 5 marks. Or you can use completing the square if you want to solve it that way. Now I am going to use factorizing on this one. So to factorize this, it's example 9. We've got 2x squared plus x minus 3 is less than 0. Now, if you're not sure how to factorize this, using, when we've got a number in front of the x squared, then make sure you look back at the old video and watch that, because that's a common question that comes up in the middle of something. You've got to know that technique. So the way I do it is I go 2 times minus 3, which is minus 6. And I want something that times is together to make minus 6 and adds together to make that middle number, which in this case it's positive x, which is positive 1. So it's going to be 1 and 6, 2 and 3. Now what adds together to make 1? Well, it's going to be minus 2 plus 3. So it's going to be 2x squared plus 2x, minus 2x plus 3x minus 3. We split it up down the middle. We factorize each side. So I'm taking out 2x here, bracket. If I take 2x out, I end up with x minus 1. Here I'm taking out 3 from each of these, which leaves you with the same bracket, x minus 1. Then when we write this out, x bracket x minus 1 plus 3 bracket x minus 1. I'm taking out this bracket as the common factor. So in front of the bracket it's going to be x minus 1. And then you're left with 2x plus 3 is less than 0. Now, take note, we still haven't really even started this question, okay? We've just factorized it, okay? The next stage we need to do is to find out what those solutions are. Well, in this case, our solutions are x is equal to, I'm going to do this quickly, take the 1 over, would be, so x is equal to 1. Take away 3, divide by 2. So this one here is x is equal to minus 3 over 2, which is equal to minus 1.5. Okay, you still probably only got about 2 marks here now, because the key part they're looking for is the graph and understanding that you know what to do when it's less than 0. So I'm going to draw my graph. It's at minus 1.5 and positive 1. These are our 2 solutions, so they're like that. It's a positive quadratic because this is positive squared. And I'm looking for when it's less than 0. So this is 0. When is it less than 0? It's here. It's connected. So that means it needs to be minus 1.5 is less than x is less than 1, like so. Brilliant. Now we've finished it, and now we've got those 5 marks. So let's just check that answer. So let's have a little look. Brilliant. So minus 1.5 up to 1. It's connected. It's worth 5 marks there. Notice that for that first part, you're only getting, if you get to this stage, you're only getting 2 marks. Okay. The rest of the marks, the rest of the 3 marks are for this part here, understanding this. Okay. So let's, one more question actually. I forgot about this question. So last little stage now is to, let's put it in context. So this one here is question 10. Okay. So here we've got a parallelogram and an isosceles triangle. And with an isosceles triangle, you know that the 2 sides, so the base and the height in this case, are going to be the same. The area of the triangle is greater than the area of the parallelogram. Okay. Work out the least integer value of x. So because we're talking about the area, first of all, I'm going to have to set up an equation which involves these areas. Now this one here is a brilliant example of one that comes up. This comes up, I've seen this come up loads in A-level. I have seen questions similar to this come up on GCSE, but it is a little bit rarer. If it is in the GCSE paper, it's going to be towards the end of it, so it's either one of the trickier topics. So I've got here a parallelogram, like so. brilliant. I've got an isosceles triangle. Base of this one is 2x. Because it's isosceles, I know that this is 2x as well. Okay. The base on this is x plus 4, and the perpendicular height on this is equal to x. So, let's work out the areas of both of these in terms of x first. So the area of this one is going to be the base times the perpendicular height, which is going to be x times by x plus 4. Brilliant, that's fine. Okay, and this one here is going to be base times height divided by 2. So 2x times by 2x divided by 2, because it's a triangle. So let's just expand these out. X times x is x squared. X times 4 is 4x. This one here. 2x plus 2x is 4x divided by 2 is equal to 2x squared, sorry, because it's times. 2x times 2x is 4x squared divided by 2 is 2x squared. Now, it says here that the area of the triangle is greater than the area of the parallelogram. So the way I do this, I do 2 dots on this side because it's greater than. I do 1 dot on this side, and I'm saying that this is greater than the area of the parallelogram. So now I set up an equation that I can solve. Okay, so let's just do this in different pen. Last little part here. So x squared plus 4x is less than 2x squared. I'm going to take these over to the right hand side, I think, to make sure that this stays positive. So minus x squared from both sides, and also minus 4x from both sides as well. So if I minus the x squares from both sides, I end up with nothing there. Minus the 4x from both sides, I end up with 0 on this side. That's the point. I want it to be equal to 0 when it's a quadratic, is less than 2x take away x, sorry, 2x squared take away x squared is x squared minus the 4x, which is there like so. So I've now created this inequality which I can solve. Okay, so to solve this inequality, well, with this one here, it is a quadratic, but it does factorize into a single bracket. So x is less, sorry, 0 is less than x bracket x minus 4. Okay, now I'm actually going to flip this right round because I prefer to have these on the equation on the left hand side. But if I flip the equation right round, I also need to flip the inequality round as well, because this one here always needs to stay bigger or greater than 0. So I'm going to say that this here, it's exactly the same, is greater than 0. Brilliant. Okay, so my two solutions here are equal to when x is equal to 0 or when x is equal to 4. Okay, so let's just draw our graph. Put this to the side. So we said our solutions are when x is equal to 0 and x is equal to 4. So it needs to be a graph. It's a positive x squared, which means that it's a U shape, and it's crossing through 0 and 4, so it looks like this: 0 and 4, 0 and 4, and we're looking at here. Now notice, this is why I flipped it round, because you might be tricked into thinking that I'm looking for when it's less than, but I'm actually looking for when this is greater than 0. So just be careful of that. If you need to make sure that you've got these things the right way around. So when is my equation or my quadratic greater than 0? It does mean say this the other way around. When is my equation greater than 0? But it's nicer to see that way. Okay. So when is it greater than 0? When it's greater than 0, this is 0. This is when it's greater than 0 on the left hand side. This is here is when it's greater than 0 on the right hand side. So it's greater than 0 when x is less than 0. So x is less than 0, or when x is greater than 4. Now it says work out the least integer value for x. I wrote 5 there, sorry. Greater than or equal to 4. It's because I'm thinking about the next stage. X is greater than 4. Now, because these are lengths, can you have a length which is less than 0? Can you have a -1, a -2 length? No, you can't. So it can't be that. So we're looking for when x is greater than 4. And it says the least integer value. Now an integer is a whole number. So if I was to draw this here, it'd start at 4 here and it'd be going right. But it's not equal to 4. So my first integer value of this is equal to, I think you can probably see it now, my first whole number is equal to 5. So the smallest integer it can be is 5. When x is greater than 4, it can't be equal to 4. It can't be anything less than 0. So my first value here is 5. So when x is equal to 5. That is a tough question there. There's loads going on. You've got to form the equation here. You've then got to solve the equation. You've then got to have it the right way. You've got the solutions, probably only 2 marks to there, or maybe 3. Then you've got your graph. Then you've got your solutions here. But then you've actually got to understand these solutions. Because it's lengths, you know it can't be less than 0. It can't be equal to 4 because it's greater than 4. So the first value is when x is equal to 5. Brilliant question. What a super question. Alright, so let's just check the answer. X equal to 5. Super, perfect. So here's some questions. I've got 2 sheets on this. So I'm going to pause now. Have a go at these yourself. So here, have a go at these questions. Okay, hopefully you've had a go at those. Remember, the only way to learn maths is to do it, so do make sure you're having a go at these. Here's the next questions for you to have a little go at. Okay, and I'm going to pop all the answers up, so mark these in green. So that's the answers to all the questions there. Brilliant. So thank you for watching this video on quadratic inequalities. Do make sure that you're having a go at these, because remember, the only way to learn maths is to do it, and have a lovely day.